Okay, so on page 67, we're going to start the exact same way. First, we have to determine how many triangles we can make, and so that way we have a game plan on what we need to do. So on page 67, number 1 says that big B, the angle B, is equal to 22 degrees, and that little b equals 16.8, and that little a is going to equal 22.42. So the first thing we're always going to draw is that side-side angle. This is an acute angle, so side-side angle. We know in here that this is 22 degrees. That's my B, which means across from it is 16.8. So this was big B, this is little b, which means A goes over here, 22.42. So, number 1, angle is blank, it's acute. So we know we're looking at cases 1 through 4. We know that this side over here is less than this side over here, which is a good thing or a bad thing. We're going to find out in a second because we need to also find our height. So let's find our height. Our height is always going to be side, sine, our angle. So side, sine the angle. So my height is going to equal 22.42 sine 22 degrees. Just type that in your calculator. You're going to get that your height equals 8.3986. So that's that minimum distance right here. This is the absolute minimum distance I could be. So if you're looking at your cases that are on, we were at 1 through 4. So because 16.8 in my swing side is, and then I have my height, 8.3986. So because this was A and this is H, so A is bigger than H, but A is less than my B, which was 22.42. Hang on, I'm going to fix these labels for you. So this was my height. In our case, we did call this one B, but it's the swing side over here, either way. And this was less than side A. That means I can swing or make, I can either swing this side out and make that triangle, or I can make this triangle. Because my green side is bigger than my height, but smaller than this side over here, then I can go out or in. And so now we're going to do the math to find all those missing pieces. But now at least we know 2 triangles. So let me grab a new page. I personally like to do this in a table. It makes things come out a lot easier for me. So what I always do is I'm going to do one triangle, then I'm going to do the other triangle. So let me split this in half because it's all going to connect to one another in a second. Oops. So the first one I'm going to find by default, I'm going to call triangle 1. So what we know right now, I'm just copying out the problem, is that big B equals 22 degrees. We know that little b equals 16.8, and that little a equals 22.42. So because I have a complete ratio, let me use my highlighter. Because I have a complete ratio, right here and right here, I can go ahead and use that, and that's what I'm going to do. I'm going to use the law of sines. So I'm going to do sine of 22 degrees over 16.8 equals sine of angle big A over side A, 22.42. And what I'm going to do is I'm going to cross multiply and then divide. So it would be sine A equals, you would multiply the 22.42 times the sine, oops, hang on, let me erase that and fix that. It was supposed to be a multiplication. Times sine of 22 degrees, and then you would have divided all this by 16.8. So I'm going to type that in my calculator real quick and get an answer, but that's not going to be your final answer. So I did control divide and got a fraction. On top I'm typing exactly what's on the paper. 22.42 times sine of 22 degrees, all divided by 16.8. It's going to tell you this is going to come out to be 0.4999 repeating, but we need to solve for A. So in my calculator, I have to do arc sine of my answer, the 0.499921. And if your calculator's in degrees, it's going to give you a degrees answer. So I highly recommend that you put your calculator in degrees. And so when you type the arc sine in the calculator of the 0.499921, you're going to get big angle A. And big angle A is going to be 29.995 degrees. We always go to 3 decimals. I'm going to box that answer. And then I'm going to grab a different color so we can color code all this. Now I know 2 angles. So if I want to find big angle C, I can do 180 minus the 22 for angle B minus the 29.995 degrees. And this will get me my angle C, because a triangle has to add up to 180 degrees. So we get that my big C is going to be 128.005 degrees. I'm going to box that one too. Box the C that goes with it. So now that I know angle C, I finally can find side C. So let's go ahead and do that. So I'm going to grab I don't know, we'll do red now. So I'm going to do law of sines again. One note, I would not use angle A. If you made an error in finding angle A or you rounded funny, that rounding will be introduced to side C when we find it. So I always go back and try to use the original ratio they gave me so I don't introduce more error. So I'm going to do sine of 22. I'm copying pretty much what I wrote in white up top. Sine of 22 degrees over my 16.8 is going to equal sine of 128.005 degrees all over side C. I'm going to grab my blue for a second. Be careful, or just make a note. This one right here where I'm putting my blue dot, I had to find an angle, so I had to do the arc sine. This one, I'm only finding little side C, and because I'm finding a side, I'm not going to have to use arc sine. So when I cross multiply, you should get 16.8 sine, cross multiply, sine of 128.005 degrees, all divided by sine of 22 degrees, and this is going to give me little side C. And so I'm going to go ahead and type that in my calculator. Control divide, 16.8 sine of the 128.005 degrees over sine of 22 degrees. And you found out that little side C is 35.338. Now the reason I told you to do this in the table is the following. They go together. The answers and the work go together. So I'm over here, I'm going to write triangle 2. When you do triangle 1, you are always finding this version that you swung it out. Let me draw the height in there. So you swung the swing side, this side over here, out. So when I go over here, I'm always finding where I swing it in. If I'm finding the skinnier triangle, And so that means this angle, let me grab a color really quick. Let me do yellow. This angle right here and this angle right here, they're the two that go together. And this is angle A. And so this was the acute angle A, and this is the obtuse angle A over here on triangle 2. And so what's going to happen is that I am going to use what I talked about at the very beginning of the video. The sine of 30 and sine of 150 have the same sine value. So what we're always going to do is take this first angle that we found. I'm going to color code it. So I'm going to grab my yellow, because the first angle that I found was this yellow thing, the A. And I'm going to do 180 minus my 29.995 degrees. Because this angle A and this angle A right here, they have to add up to 180 to make that first quadrant, the 180 degrees that I had before. And so this is going to be what I call A new. So I'm going to do that in my calculator. I'm going to do 180 degrees. So 180 minus the 29.995. So my A new is 150.005 degrees. And then I'm just going to follow what I did. So when I found angle C before, I did 180 minus 22 minus 29.995. Well, I don't have 29.995. I have this. I have 150.005. Same thought process though. So C new, exact same math, 180 minus the 22 that I had from angle B that I can never change, minus my A new, 150.005. That's going to get me my C new. So C new, if I use my calculator, it's going to be a very small angle, 7.995 degrees. So here is my C new. And then finally in red, I'm going to do the exact same math I did right here, except my angle is going to change. So I still have sine of 22 degrees over 16.8 equals, I don't have 128. I have my C new up here. I have sine of 7.995 degrees all over little side C. So 16.8 sine of 7.995 degrees all divided by sine of 22 degrees. Everything lines up and it's the same except for that 22 stayed the same, this stayed the same, but this right here, let me grab a blue, this one right here and this one right here, they affected and changed one another. So it's almost exactly the same math. Oops, sorry. Still writing in a highlighter. So let's grab the red pen. I'm going to type this in my calculator, use my little fraction tool. And if you're using some logic, since the angle C got way smaller than side C should be way smaller. So instead of being 35 something, this time I got it to be 6.238. It's little c. So this is how I usually find two triangles. Okay, let's do the next two examples on page 67, and then tomorrow you are free to work on your practice problems. Okay, so again, we're still on page, I lost the page, I think 67. Yep, we're still doing practice on page 67, so page 67, and now I'm going to do number 2. So number 2 tells us that big angle B equals 96 degrees, little side B is 3, and little side A is 24. It's an obtuse triangle, so we're going to draw side, side, and we're going to make this angle down here obtuse. So this is my 96 degrees. It was B. That means this over here is equal to 3 because little b is across from big B. That means this side right here is A, and it's 24. So question 1 is the angle is obtuse. So we only have 2 choices. Once you're obtuse, you either have no triangles or 1 triangle. So we have to compare this side to this side. And we want this side to be longer than this side so that it can reach the bottom down here. But in our case, B, which equals 3, is smaller than A, which equals 24. So I'm never going to reach the bottom. So there are no triangles. And there's no math for you to find because there's no triangles, there's no missing sides to find, and that is it. So last problem, number 3. Check. Oh, I did 67. Good. Just number 3, again, still on page 90. Oh, not 90. I did that in the last slide. Let me go. Sure. Okay. It should be page 67. Number 3. They tell me that little a is equal to 7, little b equals 9, and that big B equals 49 degrees. So again, this is acute, so we're going to draw it the right way. So side, side, angle. I drew an acute angle. This is 49 degrees. It's my big B. Little b is going to be across. It's 9. A equals 7. And then I'm going to draw my height in. So because we can look at B and A and say that 9 is bigger than 7, I'm either going to have 0 triangles or I'm going to have 1 triangle. I can't have 2. Oh my gosh, I can't spell triangle either. Let me fix that. 1 triangle. And this is why. Because this one's bigger, I can't swing down this way. It's got to be shorter. So I could have 1 triangle by swinging it out this way, but I have to find this height to see if I'm even long enough to go that way. So let's do that. So to find my red height, it's always going to be side, sine, angle. So in our case, it's going to be 7 sine of 49 degrees. And when you type that in the calculator, you should get that your height equals 5.283 approximately. So we know we're going for that 1 triangle because this side B is longer than my height, so I can swing it out and make my 1 triangle. The beauty of that is that when you get 1 triangle, you're going to pretend like you don't know the ambiguous case exists, and you're just going to solve like you did earlier all of your problems last week before you even knew this ambiguous case existed. So let me just shrink this down really quick, put it in the corner. I'm just going to do math. So my complete ratio is the B. So I'm going to do, I never put a degree symbol up here, I'm sorry. So I'm going to do sine of 49 degrees over 9 equals sine of, we're going to call it big A because it's across from little a, 7. I'm going to do my cross multiply, make a butterfly. So I'm going to get 7 times sine of 49 degrees divided by 9 is going to equal sine of A. Because you have a sine here that you're trying to solve for, we are going to have to use that arc sine. So in my calculator, I'm going to type the 7 times 49, either put your degree symbol or put your calculator in degrees, and then divide by 9. You should get this piece right here is 0.587. This equals sine of A, so we have to arc sine the 0.587 to get my angle A. If your calculator's in degrees, it'll give you the degree answer. If not, you're going to have to convert it to radians or convert it from radians to degrees by multiplying by 180 and dividing by pi. So you're going to get the big A equals 35.944 degrees. I always like it when you box these along the way because it makes it easier to find your work and your answers. Let me shrink that one down a little bit. So there's angle A. And now that I know angle A, I can do the 180 minus the 49 they gave me minus the 35.994 degrees. And this is going to get me angle C. So you're going to get that big angle C is going to be 95.056 degrees. And I'm going to do a law of sines one last time. Again, I'm going to go back to my original ratio up here and not use a rounded answer. So I'm going to do sine of 49 degrees over 9 equals sine of 95.056 degrees over little c. And so when you cross multiply, you're going to get 9 sine 95.056 degrees over sine of 49 degrees equals little c. You won't have to arc sine because you're solving for a side this time. You only have to arc sine when you're solving for an angle. So let's type this in our calculator. 9 times sine of 95.056, degree symbol, over sine of 49 degrees. And you should get that side C is 11.879. And you're all done. Hopefully this helps you guys. Remember, your teacher has office hours, and then you can go back to Canvas and work on the practice problems or options that you have for the assignment for this part of the unit. Happy math, kiddos!